Right, so we got cut off at the end of the question 1 when it was talking about the amplitudes. Is that what it says? No, it doesn't even say that. It says that the maximum distance. And it was just, if we just write the answer, it was x equal, this is just the end of question 1. It just says x equals, I have to be a bit faster, like I'm having storage props. 2 cos 3t plus sine 3t. And it's, I think it's, if you're thinking about that as like r sine x plus alpha, the maximum distance is the r, which is going to be root 5. So it's root 5, which is 2 squared plus 1 squared. Okay, so that was question 1, yeah. So question 3, it says describe the motion of the particle. It's just simple harmonic motion, isn't it? And that's what the question is like. But then, and I'm going to write d2x with dt squared because I'm conscious that the dots might not have come out that well. Equals minus, and when we do say omega squared x, that's what we say. That's your usual letter that we'd use is all. Okay, it says the acceleration is minus 5 when x equals 1. So dead simple, minus 5 equals minus omega squared times 1. So omega squared equals 5. So we've got, here's our differential equation then. d2x t squared plus 5x equals 0. And that's what we're going to solve. And yeah, again, and we'll do all that. Homogeneous second order equation. And then let's solve it then. And we've got these initial conditions that at the initial time, the velocity is 6 and the displacement is 5. Okay, so I'm going to solve it. It's x equals a cos root 5t plus b sine root 5t. Where's the root 5 from? From there. If you like, you call it omega if you wanted to. And that's x then, and I just need to, I'm going to differentiate it so I can work out a and b. But, so dx with dt equals, minus root 5a sine root 5t plus root 5b cos root 5t. Okay, and that's enough now to sub into. So if I sub in t is 0, so t is 0, I get x equals, what is it? 5. Okay, so that is saying 5 equals, just 0, t is 0, so 5 equals a, sounds okay, plus 0, alright. And then when t equals 0, dx with dt equals 6, so 6 is equal to 0 plus root 5b. So b is equal to, I'll write it nice, 6 root 5 over 5, yes. And that's not the end of the question, is it? No, it's not, but it more or less is. So x equals a, yeah. 5 cos root 5t plus 6 root 5 over 5 sine root 5t. I'm going to put them in brackets, you know. There we go. That looks nicer. Just that's the argument, isn't it? There's the argument. The argument is root 5t. The argument is root 5t. Just emphasises that. And then let's answer this question again. What's the maximum distance of the particle from O? It's the amplitude. So what would times by sine in that situation? So I'm just going to do that squared plus that squared and square rooted, and that's it. So 5 squared plus this guy squared. There we go. What is that? 25 plus, what's that? 1.2 times 5. Well, I've got that wrong, haven't I? 36 over 5 is that? Yeah. Oh, of course it is, yeah. 36 over 5. There we go. What's that? 125, 161 over 5. Get in. And that's probably the nicest way to write it. Okay, so that's question 3. Question 5 then, let's have a look at question 5. Yeah, question 5. So, about a boat, okay. Right, and it moves up and down, bobs up and down, I should say. Right, so again, let's just integrate, well, not integrate, but solve this differential equation. So we've got d2x with t squared. No, I'm off the screen there. Am I? No. d2x to the t squared, I'm going to write it this way, plus 2.25x equals 0. And look at that, they've said, write it as x equals a sine omega t plus b cos omega t. Now that's unusual for me, like I tend to put cos first, but let's do what we're told here. So that's a sine, I'm just going to go for it here, 1.5t plus b cos 1.5t. Okay, I was on like this. So when t equals 2, I much prefer this to be t equals 0, but okay, well let's do it then. So when t equals 2, x, I haven't differentiated it, I'll differentiate it now. dx with dt equals, normal, 1.5a cos 1.5t minus 1.5b sine 1.5t, is that right? Yeah. Right, okay, so when t equals 2, x equals 1.3. Right, so 1.3 equals a sine 3 plus b cos 3. Yeah, okay. And then, are we on to this? The maximum displacement is 1.3. Well, what's the velocity at the maximum displacement? I like all this, what would you call that? Like just implicit information. So, when t equals 2, dx with dt is 0, and I like that. Well, it's not amazing, but it's just something that you've got to do. So then you've got 0 equals 1.5 a cos 3. I don't like this at all. Minus 1.5b sine 3. Yeah, that's differential equations that we've got, simultaneous equations that we've got to solve. So what have we got? We've got 1.3 equals a. I'm just going to do this on my calculator. Plus b cos 3. What does it say? It says 3 significant figures, 3 decimal places. Yeah, so I'm just going to do it on my calculator. And 0 equals a cos 3 minus b sine 3. Okay. Just going to pause that. No, we'll go on, just do it quick. I don't really know how to pause as well. Okay. So, right, simultaneous equations, 2 unknowns. So we've got, I'm in radians, sine 3 x cos 3 y equals 1.3 and cos 3 x minus sine 3 y equals 0. So x is, or a is 0.183 and b is minus 1.287. Yeah, not a very elegant question, this. Okay, right, yeah, that's it. So we've got x equals 0.183 sine 1.5t minus 1.287 cos 1.5t. Yeah, don't appreciate that, me, like not liking decimals. Okay, and then what's the question say then? Are we at the time elapsed between the both being at its highest and lowest point? Oh, this is a nice question. Then might draw the graph of it. It looks something like that, some sort of sine graph. And I want that time there, from there to there. Now that's got nothing to do with the amplitude, so it's got nothing to do with that. It's all about this term here. So that is so what we would have is on a normal sine graph, the distance between there and there would be pi. So if this is being squashed so that it's 1.5 times skinnier, then that time is going to be pi divided by 1.5. Just be clear on that. On a normal sine graph, it'd be pi. This is being made 1.5 times busier, skinnier, all right, thinner. So that's why I'm dividing by 1.5. And what is that? Let's see. Pi divided by 1.5 equals, 2/3 pi. 2.09 seconds. And then criticise the model. It says large values of t, so I suppose it's to do with the c going up and down, and I would say that that might change depending on the tide. It might go up and down differently as the tide changes. That's all you can say. Like very large values of T, but for small values of T, I suppose it'd be all right. Okay, so that's all I'm doing for now. I'm going to post the even number answers later. And then I really want to have a go of question 9, which is it's a good question 9. Okay, right, nice one.